Have you ever needed to clone a hard drive, make an exact copy? Well, forget about all the clunky external enclosures or paying for fancy software. Today, we're going to look at a brilliantly simple way to clone an entire disk from one machine to another, using nothing more than two classic Linux tools and a single network cable.
So, here's what we'll cover. We'll start with the whole idea behind the one-cable clone. Then, we'll get our hands dirty preparing the connection. After that, we'll dive into the two-part command that makes it all work, cover the super important warnings you need to know, and finally, look at why this is way more than just a neat party trick.
All right, first up, let's really nail down the problem we're trying to solve here, and then introduce the wonderfully elegant solution that is the one-cable clone.
Just think about it for a second. If you had to make a perfect, bit-for-bit copy of a drive onto a computer sitting right next to you, what's the first thing that comes to mind? How would you actually do it?
Yeah, the usual answers involve a whole mess of extra hardware or some specialized and often pricey software. Your mind probably jumps to USB enclosures, maybe those fancy disk docking stations or some graphical imaging tool. And look, those things work, for sure, but they can be slow, kind of clunky, and they require gear you might not even have lying around.
But what if I told you there's a much more direct way? A method that uses tools you probably already have installed on your system, and it needs nothing more than a simple network cable to plug the two machines together.
Well, that's the one-cable clone.
Okay, so before we can start blasting data across the wire, we need to set the stage. This basically means building a tiny private little network between our two machines. Now, that might sound complicated, but I promise you it is incredibly straightforward.
It really just boils down to three simple prep steps. First, the physical part. Just plug an Ethernet cable into both computers. That's it. Second, the network part. We need to give each machine a unique IP address so they know how to talk to each other. And third, and this is the most critical step of all, we have to identify the exact source and destination disks to avoid any accidents.
And here's the beautiful part. We're creating a direct line between the two. So we don't need routers or anything fancy. We just manually tell machine A, our source, hey, you're 192.168.0.1. And then we tell machine B, the destination, okay, you're 192.168.0.2. Simple as that. And this is the command that makes it happen. You'll run this on both machines. Just remember to replace the X with 1 on the source computer and 2 on the destination. That /24 part, that's just the subnet mask that defines our tiny two-computer network. This whole command just temporarily assigns that IP to your network port, which is usually called ETH0.
Now listen up, because this next step is absolutely critical. The command sudo fdisk-l will list all the disk drives connected to your system. You have to run this on both machines and carefully check the output to confirm the name of your source disk, like dev/sda, and your destination disk. If you get this wrong, you could wipe out the wrong drive, so check it twice.
All right, with our connection all prepped, we can finally move on to the magic itself. This whole process uses a two-part command. Think of it like a digital spell, where one machine offers up the data and the other command just pulls it right across the wire.
The first tool in our combo is DD, sometimes called the disk duplicator. It's this super fundamental utility that just reads from an input, in our case, the entire source hard drive, and it writes a perfect bit-for-bit copy to an output. It doesn't care about files or folders, it just copies the raw stream of data. It's exactly what we need for a perfect clone.
The second tool is Netcat, or NC. You can think of this as our data teleporter. On the source machine, we're going to tell it to just sit and listen for data on a specific network port. And on the destination machine, we'll tell it to connect to that port. It's what creates the digital pipe that's going to carry all that data from one computer to the other.
And here is where it all comes together. See that vertical bar? That's a pipe. It sends the output of the command on the left directly into the input of the command on the right. So, on the source machine, DD reads from the input file dev/sda in 64 kilobyte chunks. That's the BS equals 64K part. It's just for efficiency. That data then gets piped to Netcat. The -L-P9000 tells Netcat to listen on port 9000. Meanwhile, over on the destination machine, Netcat connects to the source's IP on that same port, receives that stream of data, and pipes it into its own DD command, which writes it to the output file dev/sda. It's a direct data firehose from one disk to the other. Pretty cool, right?
So, now we are ready to actually execute this thing. But this is the point where we have to be extremely careful. You know, powerful tools demand a whole lot of respect.
I really cannot stress this enough. The second you run that command on the destination machine, every single bit of data on that target drive is going to be overwritten. There's no confirmation pop-up, there's no undo button. Everything will be gone, replaced by the clone.
So, before you hit enter, please run through these safety checks. Triple check that your source machine is sending and your destination is receiving. If you mix those up, you will wipe your original disk. Also make sure the destination disk is at least as big as the source disk. And finally, be patient. A big hard drive can take hours to clone.
You know, one of the downsides of this command is that it gives you no feedback at all. It just sits there with a blinking cursor, and you're left wondering, is this thing even working? Well, we can fix that. There's this awesome little utility called PV, which stands for Pipe Viewer. Its entire job is to sit in the middle of a data pipe and show you what's going on, how much data has gone through, how fast it's moving, and it even gives you a nice little progress bar. And this just beautifully shows the power of the command line. You just install PV, and then you literally drop it right into the middle of the pipe on the source machine. PV just takes the data from DD, it measures it, shows you the progress, and then it passes it right along to Netcat, completely untouched. It's such a simple and elegant upgrade.
So we've learned a really cool command line trick, but honestly, it's so much more than that. This is a genuinely professional technique that has some very serious applications.
In a professional environment, this method is fantastic for quickly rolling out a perfectly configured operating system onto a bunch of identical machines. It's also an incredible way to create a perfect, low-level backup of an entire system, or, of course, to restore from that backup. It could even be a total lifesaver in data recovery, letting you clone a failing drive before you try to repair it.
So the big takeaway here is this. You have just unlocked a way to clone disks that is fast, efficient, and relies only on fundamental tools. It frees you from needing any extra hardware or specific software. It's a seriously valuable skill for any power user or sysadmin to have in their back pocket.
And that leaves us with a final thought to chew on. The real magic here wasn't just in DD or Netcat by themselves, but in how they were combined with a simple pipe. It really makes you wonder, doesn't it? What other simple, focused tools that you already have could be combined to create some surprisingly powerful results?